Hi, I'm Jasmine.
I'm Bryant.
And I'm Alex.
And we're Team Lunar Horizon.
How our robot chassis started out was with 4 treads like this, except they were separated from each other, which left a gap in the middle. It climbed over the wall as well, but then when it went to the middle, it would get stuck and it would stay at the top and not be able to move. So we fixed that problem by making them overlap each other.
As you can see from the bottom, there's just a mere set of beams and 2 motors and 4 treads. That's pretty much it. But the nice thing about this design is that it can bend up and down to climb over the crater ridges. I'm going to talk about the grabbing attachment. A simple but effective attachment on our back motor right here. Now with this curved design, the loops actually remain on the motor.
Hi, I'm Jasmine. This camera that we're using is a mini camera to video the whole mission. This is the compass sensor. It's very sensitive. And the ultrasonic sensor.
Our robot can get to the correct areas it needs to, even if it's like spinning out of control in here. It uses a combination of both the compass sensor and the ultrasonic sensor to find its way out. First, use the compass sensor to find the correct compass heading. Then use the ultrasonic sensor to tell it how far forward it needs to go.
We decided to create our own mini programming language using the NXT software as an interpreter for the code. The code is like a little script, so it's based off a text file loaded onto the NXT. Some of the commands that we have are calibrating, convert degrees, end the program, going forward for a certain distance, forward until the ultrasonic sensor sees something, grabbing a loop, position wall, which will be explained later, setting the north direction, taking the picture of the wall, and turning to a certain degree. To make this program really simple, we use a file access block to read our little script, and then it reads each line individually and checks it using the switch statement right here. One of the main my blocks we use is a command called turn to, and this is the key of our robot program right here. It uses the compass sensor, and it spins around until the compass sensor and the robot face a certain direction.
So for our programming, we use this text to make it really simple. This is a part of it. For forward, we make it go the amount of centimeters we want it to. Then we have position wall to measure degrees and then face in that direction and move the amount of centimeters it wants to away from the wall. And turn, we have a turn to make it turn to the degrees we want it to. And then we have these grab loops to make the hook move.
This is our Java simulation that we wrote up for our robot right here. And it took us a couple days to do it, and it uses the exact same scripting language that we created for our NXT robot. The camera shows where our robot takes a camera picture, all the red dots show waypoints where it turns, and the minifigure hand shows the points where our robot attempts to pick up the loops. And I learned a lot how to program in real Java by doing the simulation.